Hello everyone! Today, we are diving into a fascinating and subtle detail of IR spectroscopy, hot bands. You have probably seen the main, strong peaks in an IR spectrum that help us identify functional groups, but what about the tiny, weak signals that sometimes appear right next to them? Those could be hot bands, and understanding them gives us a deeper insight into molecular behavior. To get started, let's quickly remember the basics. Molecules are constantly vibrating. In IR spectroscopy, we shine infrared light on a sample, and the molecule absorbs energy, causing it to jump from a lower vibrational energy level to a higher one. The most common and intense transition we observe is from the ground state, which we call V equals 0, to the first excited state, V equals 1. This creates the strong, main peak known as the fundamental band. But here is the key idea. Not all molecules are in the ground state at any given moment. At room temperature, or any temperature above absolute zero, molecules have thermal energy. This energy is enough for a small fraction of the molecules to already be in the first excited vibrational state, V equals 1. They are essentially pre-warmed, or hot with a bit of vibrational energy. A hot band is the absorption of light by one of these already excited molecules. Instead of making the usual jump from V equals 0 to V equals 1, it jumps from the first excited state, V equals 1, to the second excited state, V equals 2. This V equals 1 to V equals 2 transition is what we call a hot band. The name hot band is very fitting because the population of molecules in the V equals 1 state is directly dependent on temperature. If you heat the sample, more molecules gain enough thermal energy to occupy the V equals 1 state. Consequently, the hot band signal becomes stronger and more intense. This temperature dependence is a classic way to confirm if a small, mysterious peak is indeed a hot band. So, where do they appear on the spectrum? Due to a property called anharmonicity, the energy gaps between vibrational levels are not perfectly equal, they get slightly smaller as you go up in energy. This means the energy required for the V equals 1 to V equals 2 transition is slightly less than the energy for the V equals 0 to V equals 1 transition. As a result, the hot band always appears at a slightly lower frequency, or lower wave number, right beside its corresponding fundamental band. It often just looks like a small shoulder on the low-frequency side of the main peak. In summary, hot bands are weak peaks that originate from molecules already in an excited state, appear at slightly lower wave numbers than the fundamental peak, and their intensity increases with temperature. Thank you so much for watching. If you found this explanation helpful and want to learn more about the details of spectroscopy, please consider liking this video and subscribing to the channel. Your support allows us to continue making educational content like this. See you in the next video.